Okay, good. Okay, so I'm going to go through these. I know you can all read, but some of them require some clarification. And so I'm going to work my way through that. Submissions for the week. There's drop boxes for almost everything that you need already posted. If it's not posted, then I will post it soon. So, and I'm going to jump ahead down to number 4. I revised the week 1 playlist for today. I'll explain that in a second. But you'll see drop boxes for all the individual free response questions. Those are all due by Friday at 3 o'clock. And so this week on the playlist is E1, G1, and G2. And then the remainder of that multiple choice, so up through 56, those are all turn-inable right now. As time goes on, we're going to do a bunch of different things with these, in particular the free response questions, since that's what the AP test will involve. So for instance, this week, after Friday at 3 o'clock, I will post solutions to just about everything for the week. And what we do with those are very different. So for instance, for E1, I will post the grading rubric, but I've also created a video where I recorded, similar to what we would do in class if I was going over it, talking my way through the solution to try and give you some points that'll help with that. For this week, E1 and G2 will both have videos. So if you, ideally what you would do is you would look at the grading rubric. If it makes sense, you're good to go. If it doesn't, you can watch the video where I try to explain a couple other things. If none of that makes sense, then that's where you would make use of either now for class time or office hours to jump in and ask some questions about those particular things. For this week's G1, we're going to do something different. When I post the solutions on Friday at 3, I'm going to ask you to grade your own free response. Grade it out of 9 points. You'll see on the grading rubric how it's supposed to be graded. Grade it to the best of your ability. There might be some things you're a little confused about. I would suggest you grade tougher than you would normally. Obviously, you're going to want to give yourself a ton of points. But again, the points don't matter. This is all going, if you do anything, it's going to help your grade. So focusing on this being a learning experience, grade that as accurately as possible. And then when you get done grading it, that's, by the way, that's what GYO stands for, grade your own. You'll post the score into a quick quiz on Schoology, okay, just so I have a record of how you scored. Next week, I will change that up a little bit. We'll have a couple more videos. You'll grade one on your own, but then I'm also going to grade one. So I won't post a solution right away. I'm going to go through and grade them because I think it's important that you see the difference between how I grade versus how you grade compared to what the rubric says. Okay. The questions of the day have been posted. I've been keeping up with that, and I don't think I've screwed up anything. Today's is a little weird. There are no questions. The questions is the quiz itself. So for some of you that have done it, it's a simple, how are you? In fact, I think the question is, how are you doing today? It's a 1-question quiz just to check and see how everybody's doing. So easy, answer the question, move on. Other days, like the last 2, you'll see a couple multiple choice questions going from there. Okay, and then I help me out on this. Did you just get an email from me about a wellness survey? Because I don't remember if I sent it out yet. Can somebody check their email?
You did. You just sent
I got it.
I got it. I already did it.
Beautiful. So,
Yeah, you did.
Sometime today, if you could fill that out so that I can see how you all are doing. I really do care how you're doing, not calculus-wise, but mentally and physically. Down at the end, I went on a little rant about what I've been doing. If you want to read that, great. But just to check in with you on an individual basis and see how everybody's doing. Okay, so get that done by the end of the day. I'd appreciate it. Before we move on, does anybody have any questions about anything that's been happening so far? How to submit things, what's expected, blah, 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 blah. If so, just unmute and ask.
Sometimes Schoology is down. What do we do in that case?
The same thing I've been doing. You just got to keep hitting refresh and wait until it pops back up. Obviously, if it crashes for an extended period of time, then we'll do the best we can with it. You know, I would not wait until Friday at 2:45 to submit all your stuff in Schoology. If you submit it as time goes on, it'll be a lot easier and less likely for you to miss some deadline. The other thing I forgot to mention, which again, I'm forgetting what I'm posting and what I'm not, but I will post the solutions to all the multiple choice greatest hits problems Friday at 3 o'clock also. I managed to scan my solutions, and I'll make those available for you at the end of the week. I think that's all I had for you, unless somebody else had, I mean, not all, I want to do some calculus also, but until then, are we good to go with any nuts and bolts of how things work? Any other questions? And 3, 2, 1, we're good? Okay, in that case, I wanted to ask specific questions about those 4 things that you should be working on. MCGH obviously is multiple choice greatest hits, E1, G1, and G2. So let's try to keep this somewhat organized and start with questions from the multiple choice greatest hits. Does anybody have any questions on any of those problems? And I'll give you a couple of minutes to look through that. While you're looking through that, I'm going to check to see who's been entering and leaving our session.
I have a question.
Go ahead.
It's number 8. I'll just say it out loud. So the limit as x approaches infinity, 2 to the negative x over 2 to the x equals.
Let me find my solution here. Okay, so I should be able to do this and jump into Notability. There we go. You can see that, right? Okay, good. Let me go back to my screen view so I can see. Okay, so the problem says, what is the limit as x approaches infinity of 2 to the, whoops, 2 to the negative x over 2 to the x, right? Okay, so that's the same thing as the limit as x approaches infinity. Remember, you got to write the limit every time of 1 over, 1 over, stop it, 1 over, okay, why does that keep happening? Okay, oh, I know what it's doing. Okay, 1 over 2 to the x times 2 to the x. You with me? Negative exponent moves it to the bottom. Okay, which is the same thing as the limit as x approaches infinity of 1 over 2 to the 2x. Which means this bottom is going to get really, really big. So if we have a fraction, and that fraction is 1 over something, if that bottom gets really, really big, what happens to the entire fraction? The entire fraction approaches 0. Okay, so as this approaches infinity, the whole fraction goes to 0. And as we've talked about in the past, if the bottom approaches 0, then the whole fraction approaches infinity. Denominator gets very small, fraction approaches infinity. Denominator gets very big, fraction approaches 0. Okay. Other questions on the multiple choice?
Can we go through how to do number 10?
Yep. Okay. Let's see. Scroll. Whoops. Okay, so number 10 is the limit as x approaches 0 of the sine of 3x over the sine of 4x. All right, what's the first thing you do with any limit problem?
Plug and chug.
Plug and chug. Great. So we put in 0 there. We get the sine of 0, which is 0, and the sine of 0, which is 0. What does that mean? We've got an indeterminate form. And for indeterminate forms, you then use the hospital. Okay, L'Hopital's. And what does L'Hopital say? L'Hopital says, well, if I have an indeterminate form, then I take the derivative of the top, the derivative of the bottom, and plug and chug again. So this becomes the limit as x approaches 0. Derivative of the top, let's see, derivative of sine is cosine of 3x, and I'll have a 3 out in front because it's a chain rule going on there. The bottom would then be 4 times the cosine of 4x. Plug and chug again. Cosine of 3x, or yeah, cosine of 0 is 1, cosine of 0 is 1, so this gives me 3/4. Good. Okay. What else?
Number 22, please.
Changing colors, 22. Okay, y equals x squared times the sine of 1 over x, and we're looking for y prime. Okay. Two functions, x squared and sine of 1 over x, therefore we have to use a product rule, which would give me y prime is equal to the derivative of the first times the second, plus the first times the derivative of the second. So the derivative of sine of 1 over x would be the cosine of 1 over x times the derivative of 1 over x, which is negative 1 over x squared. Okay, now I made a big jump for that. I've been doing this a little bit longer than you guys have, but are you okay with that transition from the derivative of 1 over x to negative 1 over x squared? What you may have done is written this as x to the negative first, and then taking the derivative of that by bringing the exponent down and reducing it by 1. Remember, negative 1 minus 1 is negative 2, not 0. Now, I don't know if you need to simplify that at all. Let's see, 22.
You had to because of the answers.
Yeah, it doesn't match in the answer. So how does this simplify? Let me see. Oh, it would involve this. So, whoops. I meant the highlighter there. This times this would simplify to a negative answer. So I'm guessing the answer would then be 2x times the sine of 1 over x minus the cosine of 1 over x. Is that one of the choices? Yeah, D as in donkey. Yeah, this is so weird. It's actually like teaching again. I missed it. What else we got?
Number 17.
Okay, this is a fairly common type of problem where they give you some function and they define it in terms of two other functions. So f of g times, or f times g, and they want to know b prime. And so it's kind of interesting that we pick these problems because they all tie together. Notice in 22 we had to do a product rule. In 17 then we have to also do a product rule. So the derivative of the first would be f prime times the second plus the first times the derivative of the second. All right, so that's the general expression. And now if we want b prime of, what is it, 2? Yeah, of 2. Then you go to the chart up above and fill in everything we need to know. So f prime of 2 would be 3. G of 2 is 1. F of 2 is 5. And G prime of 2 is negative 2. Which would give me 3 minus 10, which is negative 7. And hopefully that's one of the answers. It is B as in badger.
Can you do 28?
I hope so. Okay, so before we dive into 28, let's talk about the concepts here. The tangent to the curve of blah, blah, blah is horizontal when x is equal to blah, blah, blah. Okay, so what is that asking me to do? Anybody, feel free to, I mean, it doesn't have to, I don't even know who asked. All I'm hearing is voices now, so. Anybody want to chime in?
Is it derivative?
Yeah, and then what? What do I do with that derivative?
Would you put it equal to the other side?
Mm-mm. What can you tell me about a tangent line that's horizontal?
Equal to 0.
Equal to 0, good. So what we want to do is we want to take y prime and set it equal to 0. And then solve for x. So that's the gist of what we're going to do. Now the mechanics for this particular problem has y being equal to x times e to the negative x, which is again another product rule. So y prime is equal to 1 times e to the negative x plus x times negative e to the negative x. Okay. Because the derivative of e is itself, and you have to chain on the derivative of the exponent up on top. And we want that to equal 0. Whoops. Okay, so conceptually, that's what we need to do. Now, the problem is it gets a little tricky answering the question here. So what I would do is factor out an e to the negative x. So I would get 1 minus x. I think I did that right. Yeah. So therefore, what's x equal to? Anybody? Bueller?
1.
1. Okay, what about this? Because this is a zero product rule. I have the first part, e to the negative x times 1 minus x equal to 0. So therefore, they should equal 0. One answer would obviously be 1. When does that equal 0?
0.
It
Would the
never
x
equals
go to
0.
Never, correct. Is Megan, I think that was you. Never equals 0. Because remember, it's asymptotic. Okay, so therefore,
Negative 1.
our only answer would be 1 in that case.
Can we do number 20, please?
Yes. So 20 is, we just did 17, so it's basing it off the same idea. And so our explanation would be 20. This function m is defined as f of g of x. So we have a composite function. So the derivative of a composite function, m prime, would be equal to f prime of g of x, derivative of the outside function, chained on with the derivative of the inside function. Okay, and we're doing m prime of 1. So that means I need, this becomes this. Okay, so going back to the chart, let's see, g of 1 is 3, so now this becomes f prime of 3. G prime of 1 is negative 3. And then f prime of 3 is 4, so we get 4 times negative 3, which hopefully negative 12 is one of the answers. Is it? Yep, it's A, as in aardvark.
Could we go over 49 and 50?
Yeah. 49. Okay, good. Let's do a quick review then before we dive into this particular problem. We start with a velocity function, and we know that the integral of that velocity function, we have two scenarios. We have that versus this. One of these is displacement, one of them is total distance. Which is which?
The first one's displacement.
Top one is displacement.
Whoops, I can spell. Displacement. This is total distance. Okay, now the question is, how do you know that? I'm sure some of you just memorized it. Some of you may have looked it up quickly, but do you have a technique to remember which is which? I have one which I'll explain in a second, but I'd like to hear what you have. Go ahead.
Can't displacement be negative? But the total distance can't be negative, so that's why there's the absolute value.
Correct. Good. So I remember it this way. I remember if I start here and I move forward 4 feet and I back up 4 feet, my total displacement is going to be 0. And when you take the integral, it's going to give me this answer as a positive, but that's actually going to be negative. So the displacement has to take into account negative distances. Total distance is going to take all of this and make it positive, so it's usually a bigger number. So yeah, I think that was you, Faith, right?
Yeah.
Okay, good. All right, now that having been said, if we take a look at, Drew, was it 49 you said?
I never said anything.
No, it was Michael.
Michael, okay, I screwed up on the voice there. So in this case, we want to go 0 to 3. And since we're doing displacement, we want to do v of t dt, which in this case would be 0 to 3 of t squared minus 4t plus 3 dt. Plug and chug and solve. Okay. Versus problem number 51, which is the same problem, except you got to slap in some absolute value bars in there. And I would probably use a calculator for that one, because we don't really know how to do an antiderivative of an absolute value.
What's the middle variable that you wrote there?
That's a t. Okay, we good? Anything? Go ahead.
Could we go through how to do 24?
Oh, this one's a pain in the butt. Yeah, but we can do it. Okay, so let me draw a picture first. That might help a little bit. Okay, so I've got a function that's some type of cubic, so let's pretend it looks something like this. And we've got some points on this cubic. One is at 0, so that'll go through, I think it's 0, 0. Yeah, 0, 0. And then another one is over here at the square root of 3. We'll put it up there. This is 0, 0. Can I find the y value of this point? Yeah. Put in the square root of 3 into the function. By the way, the function is f of x is equal to 2x cubed minus 6x. So if we put in that square root of 3 into there, we get, let's see, 2 times the square root of 3 cubed minus 6 square roots of 3, which would be 3 times 2 square, 0? Yep. So my graph is completely whacked, because that should be 0 also. Okay, so anyways, my graph is off, but hopefully we'll get an idea of what's going on. This would be the secant line connecting those 2 points. And we want to know where along this curve then is the tangent line through that point going to be the same as a tangent line there. In other words, those things have to be parallel. Okay. Now, to do that, I would do two things. I would calculate that slope using Algebra 1, and I would find the slope of that using calculus. How do I find M2?
Derivative.
Good. Find f prime of x. Then take this equation for f prime of x and set it equal to that value from Algebra 1. And we can tell already without doing any calculations that the M1 should be equal to 0 because they have the same y values. But again, you go through the process and, by the way, this is a variation of the mean value theorem. Slope from algebra equals slope from calculus. Okay, let's take a break from the multiple choice for a second and take a look at the free response questions. I'm going to assume that you've at least looked at the free response questions. I might be wrong. If you haven't, then just roll with it. But I wanted to talk a little bit about the topics that are on each of these things. Okay. In E1 is the bike ride problem with Karen. This is a pretty popular type of problem that equates a velocity function or gives you a picture of a velocity function and asks you a bunch of questions about that velocity function. As soon as you see a picture like this, there's a pretty good indication that you're going to be doing some geometry stuff. You got some nice triangles there, you got a trapezoid, you got rectangles, you got all this fun stuff to work with. Okay. And as a quick refresher, we have three possible functions here. S of t, the position function, v of t, the velocity function, and a of t, the acceleration function. Remember, if we go from that to that, that's a derivative. And if we go from this to this, it is an integral. Okay. And since that's a graph of v of t, the velocity, then if they want to ask you about position, then you're going to take an integral. If they want to ask you about acceleration, you're going to take a derivative. And how do you take a derivative? Also remember that the integral represents the area under a curve. So you're going to be doing some calculations here. And in this case, remember that's a negative area. One last tip I'll give you on this. This one's a little weird. Notice the y-axis is not whole numbers. They're tenths. That's going to become relevant when you do some calculations. Okay, and then before we move on, let me ask you a question to get some audience participation going on here. Karen starts here and she rides to school. Can somebody describe what her route looks like along this straight path to school? What did she do? And that's not an easy question, by the way. What happens here?
She turns around to go back home.
Beautiful. What happens here?
She leaves her house.
Nope.
Oh, she got to where
stopped at
she
home.
turned around.
Say again, Michael.
Did she get to where she turned around?
Isn't that just she gets home?
This location is actually when she gets back to her house.
She stops at home.
Right. And
Yeah.
then this business here is she's doing whatever she's doing at home. She's looking for her homework. She's making a peanut butter and jelly sandwich. Who knows? What happens here?
She goes to school.
Yeah, she goes back to school. So notice that the area of this triangle and the area of this triangle are the same except negatives because she goes out the same distance as she comes back. So this ends her back at home, and then she screws around for a little while, and then this is the actual route that takes her back to school. Okay? So that should help a little bit with E1 if you haven't already dove into it. And if you have, that might act as some clarification. Okay, let's take a look at the other one. The other ones for this week are G1. This is a particle problem similar to some of the ones we just talked about in the multiple choice, where you've got a particle that is sitting on the x-axis bouncing back and forth. If it's going to the right, its velocity is positive. If it's going to the left, its velocity is negative. If its velocity is equal to 0, it's stopped. Okay, so you'll notice in part C, total distance, we just talked about it. Let's talk about speed. How does speed differ from velocity?
Speed can't be negative.
Good. So speed is actually defined as the absolute value of the velocity. Excuse me. And one of the things that I'm sure I mentioned at some point in time, but we can talk about speed being increasing or decreasing. Which is basically what A is asking you, but something to notice, the speed is increasing if both the velocity and, whoops, I did it again. If the velocity and the acceleration are both have the same sign. So if the velocity is positive and the acceleration is positive, the speed will be increasing. If the velocity and the acceleration have different signs, it'll be decreasing. Okay, and then the rest of that problem I think is pretty straight. Well, I don't know if it's straightforward, but there's no sneaky tricks in there that I can help you with. It's just a matter of grinding that business out. And then last but not least, as far as free response for this week goes, is G2. And G2 is what we commonly call a chart problem. A bunch of information is given to you in a chart, and you have to decipher what's going on here. I would highly recommend, when you see a chart problem, to take some time and draw a quick sketch of the data. Because you know, most of the time when you have a chart problem, it's going to end up being some type of Riemann sum problem. Okay, so I would do something like this and then see, okay, 0, 2, 5, 0, 2, 5, 9, I think it's 10. Yeah. Okay, so 0 is up here at 66. And then 2 is down here at 60. 52, 44, 52, 44, and 43. What did I say? 52, 44, 52, 44, and 43. Because again, I haven't looked at the questions yet, but I'm guessing at some point in time, they're going to ask you to either do a Riemann sum or a trapezoid rule. Okay, so let's see what it says. This is a cooling problem. Use the Taylor approximate temperature with time changing. Okay, so approximate the rate at which the temperature is changing. What does that word rate imply? What should you do calculus-wise?
Derivative.
Good. I've mentioned this before, but I'll say it again. If you have a quantity and you want to go to a rate, that's a derivative. If you have a rate, and my pen stopped working, come on. Oh, my pen's dead. Now I'm screwed. Hold on, kids, we're experiencing technical difficulties. I don't even know if I can do this. Can you write with your pen while it's plugged in? All right, I give up. Why can't I write?
We don't have pens.
Oh, that's right. You guys aren't freshmen. Oh,
We don't have that luxury.
I know it sucks, doesn't it? Life's tough.
They need to rub it in.
Use your hand like the rest of us.
I know, but it's
Like
not
a
working.
peasant like us.
Or use like really bad versions of the pen.
Maybe double tap and swipe up on the app.
There is no app for the pen. All right. Anyways, I'll just talk my way through it, and then we'll figure out what's going on from there.
I think you have to select at the top, like your something else. Like you have to deselect the pen.
Yeah, but I don't know how to. Wait, hold
Just tap the normal pen.
on. Now it keeps scrolling.
Go
You
back.
tap the
Oh, wait,
pencil.
wait,
and
I got it.
click
Disconnect
disconnect.
Apple Pencil. Got it.
There you go.
Now we're in business. Oh, nice. Now I can write with my big fat finger. Rate to quantity. Quantity is an integral. Oh my God, this is horrible.
Welcome to our lives.
Yeah, I know. The struggle is real, kids. Hold on. Oh, I have a stylus. Woo! It's the simple things in life. Okay. So, rate to quantity is an integral. Quantity to rate is a derivative. So in this case, we have a quantity. We're looking for a rate, so you need to take a derivative. The problem is you don't have an equation for that thing. So you have to figure out how to take a derivative, and that will involve the slope of a secant line. The key here is notice the word approximate. Part B, you can figure that out. Part C is going to take a little bit of work. And then like a lot of these problems, part D, it ramps up really quick. So part D is definitely going to be the more challenging part of that problem. Okay. Those are the three free responses we have for this week. So that takes care of E1, E2, and G2. Are there more questions on the multiple choice?
Yes.
Go ahead.
Sorry, let me find it. Can we talk about the 34?
Ooh, little related rates. Okay. So we have a circle. Actually, we have a sphere, which is a balloon.
Wait, sorry, what number was this?
34. Okay. If you'll recall related rates, we've got a bunch of information. Everything's in terms of time because it's a related rate. It's related to time. And if you go back in your notes, I had something called a 9-step method that will talk you through it. I don't know if I'll get all 9 steps in here, but I'll take you through it at least. So I drew a picture. I've got a radius of that thing. What do I know? I know the balloon is being filled with at a rate of 4 cubic feet per minute. So that would be dV dt would be equal to 4 cubic feet per minute. And notice that that value is positive because the rate is filling, it's getting bigger. The surface area, the rate at which the surface area is increasing when the volume is, okay, so we're looking for dA dt when what? V is equal to 32 pi over 3. Okay, so that's my basic setup for the problem. And now solving that problem is going to be a little bit trickier. It's a sphere. So the volume of a sphere is 4/3 pi r, come on, pi r cubed. And then what? we also know that the surface area of a sphere is 4 pi r squared. Okay, so somehow I have to figure out how to relate these two together. In a normal related rates problem, you would just take the derivative of that and plug and chug what you know, but there's a problem here. So let's start by taking a derivative of this. dv dt is equal to 4 pi r squared dr dt. Oh, how convenient. If I come over here and take the derivative, I get dA dt is equal to 8 pi r dr dt. Okay. Is there a way, let me rephrase my question, how would you relate those two, knowing that I know dv dt, I know v, but down here I've got dr dt in r's. How do I take this into account?
Do you solve for R?
Yep, very good. If I look at that snapshot, I'm looking for when v is 32 pi over 3, which means if I set that equal to 4/3 pi r cubed, I can solve that for r. The 3's would cancel. My stylus sucks. The pi's cancel. So 8 is equal to r cubed, so r conveniently enough is 2. That allows me to plug that in there. I know what that is. So if I look at just this equation, I can solve this equation for dr dt, which is not what this is asking. This is asking for dA dt, but if I take that value, I can bring it in, plug it in there. I know what that is because we solve for that over here, and then solve for, and then solve for dA dt. Okay, that's kind of a nasty problem, but solvable. And looking at that, it looks like a complete train wreck, but can you follow that? Most related rates problems are going to be a little bit more simple than this, and they're going to take this, ask you to find the derivative to get that, and then ask you questions about that derivative. This is a multi-step one where you have to incorporate the surface area. More than likely on the AP test, you would see a question like this, but it would say, what is, let's say, what is the rate that the radius is expanding when the radius is equal to 2? So you would solve for, let's say, dr dt. Anything else? We're good? Okay, I know that's a lot of information in an hour, but you know, it is what it is. So let me stop this screen recording, or my sharing there, so I can see more of your bright shining faces. Tell me about, let's talk a little bit about semantics. How's the workload been this week? Again, I'm assuming most of you are working on these problems and doing what you need to do. So those of you that have, is the workload reasonable, first of all? Okay, shake your head or chime in with a yes or a no. Yeah, okay, good. Is everything clear as far as turning things in? And most of you have been, not most of you, you've all been really good. Where I've screwed up, I've received an email right away from people saying, oh, this isn't up, that you need to do this, you need to do that. So I appreciate all of that. It makes things a lot easier for me to be able to correct those things promptly. Next week, we're gonna repeat the same thing like I mentioned earlier. I'll put a playlist up Monday morning. It'll outline all the activities for the week. That'll kind of be a fluid thing where I might change it as we go along. The only thing I would say that you need to do after Friday, between Friday and Monday, is somewhere in there you need to grade your own G1 using the rubric that I post Friday after 3 o'clock. And then sometime Monday, you'll need to submit your score, how you did. You know, whether you got a 0 or a 9 or anywhere in between. Just throw that into Schoology so I can get some feedback on how you did on it. Okay? Am I forgetting anything? No? Okay. We're still missing 2 people. Who never showed? Audrey, you're here. You joined in. Did Philip ever show up? Philip, are you here? Okay. And Andrea, is she here? Okay, those are my 2 that I'm missing. So I can send them an email and figure out what's going on. Okay. Other than that, go ahead. Somebody's talking.
Me. So then every Wednesday at what time is it? 1?
Yeah.
We have our.
Yeah, this is the only thing, the only Zoom that is mandatory for all of you is this is our required class time. So every Wednesday at 1 o'clock. And I think most of you have picked up on this, but some of you may not have processed it yet. But I have office hours every day. I've set aside Tuesdays and Thursdays for calculus. Let me confirm that real quick so I don't give you misinformation. Yeah, I've set aside Tuesdays and Thursdays exclusively for calculus. However, I'm having office hours every day, Monday through Thursday, from 11 to noon. If you have questions, basically all I'm going to do is I'm going to have my Zoom up and running. If you want to chime in, it literally chimes. When you join the Zoom, I get a little doorbell sound and I'll know that you're there. I met with 3 or 4 people today during my office hours. They jumped in, asked a couple questions and jumped out. You're more than welcome to do that. I know that this large class situation isn't necessarily a great place to get individual help because I know that, like for instance, some of you are sitting through us doing problems that you may have already done. If you don't mind that, that's great. But I did want to give people an opportunity in this class period to ask some questions. So we got the class time. The office hours are there if you need them. As I've mentioned in the past, I'm going to use Schoology and Zoom as a format to get information out to everybody in a large group situation. If you have individual issues, that would be something that you can drop me an email with or on. Like I said, some of you have been great about helping me out with things that I screwed up on or things I forgot to post. If you need anything, send me an email, let me know. Does anybody else have anything for me today? Are we good? Okay, so let me review real quick and then I'll let you go. Wellness survey by the end of the day. It's in your email. It's a Google form. So a couple people said they did it. How long did it take you? About 2 minutes?
Like 3 minutes. It was not a lot.
Okay, good. If you want credit for this week's work, you've got 4 things due by Friday at 3 o'clock. That is the 3 free response, E1, G1, and G2, and the last half of that multiple choice greatest hits. Today is April 1st. I didn't think to do an April Fool's joke, but this isn't really necessarily a good year to do April Fool's jokes. April 3rd, the College Board is supposed to announce exactly what our AP test is going to look like. So by the end of the week, we'll have a better idea of what we're going to be working towards, which also might require that I change the approach that we, or the direction we're headed. Okay? Anybody else have anything for me? We're good? Give me a thumbs up. Awesome. Have a great week. Don't work too hard. Stay healthy, most importantly. And again, for the 9th time, if you need anything, reach out. Okay? We good?
Thank you, Mr. Reedy.
Bye, Mr. Reedy. Thank you.
Have a great day, guys. We'll see you
Bye.
later.
Bye.
Bye. See you later. Thank you.